So I left you right before this proof. They want us to look at the proof of the isosceles triangle theorem. So they want us to draw the bisector of the vertex angle. Now, there's a difference between draw and construct. Um, we're not doing a construction. It's certainly possible. I can do a construction, and if you want to see the construction, I'll be happy to construct it for you. Send me an email that says, "Hey, show me how to construct the angle bisector." It was a lesson, or if it's hasn't been a lesson, it's going to be a lesson. A whole bunch of constructions, but you will need a compass, and if you don't have a compass, then you can't do construction. So and not the compass that tells directions, but the compass with the little pointy stick and the pencil. That's what I'm talking about. That makes circles. We're not going to construct it because we can just draw. We can draw it in because we know that if you have an angle, then it is possible to take that angle and to make two congruent angles. You can take anything and cut it in half. Okay, that's the beauty of mathematics. You can take half of anything. So if given angle B right there, and B has to be the vertex angle because A and C are the base angles, we can cut angle B in half. So we know that we have two equal pieces. And I'm just kind of thinking about a proof. How am I going to prove that two angles are congruent? Well, one way you can always prove that two angles are congruent is to prove that they're part of congruent triangles. So I'm thinking about what are those ways that I can prove two triangles congruent? You remember, you've got several of them. You got side angle side, side side side. You've got angle side angle. You've got angle, angle, side. You've got right, hypotenuse, leg. You've got all those ways. So would one of those methods right here work in this situation? I'm seeing it. I've got a pair of sides right here. I've got a pair of angles. And then this side, that line that we drew is going to serve as that third side. And it looks like to me we have a situation of side angle side. So we've kind of thought it through. For time's sake, I'm going to jump over here to the teacher's version, and we're going to look at, let me erase all this. We're going to look at the proof. And they said, here's a sample proof. It's a paragraph proof, so it's not going to doesn't have to be word for word. So they're saying, hey, you told me it was isosceles. So since it was isosceles, what does isosceles mean? Isosceles means that you have two sides that are congruent. So they wrote down the two sides that were equal. I would have put AB is congruent to BC. That's what I would have put. Um, then they said, you also told me to make an angle bisector. So what does an angle bisector give me? It gives me these two angles that are congruent. So they gave me congruent angles. So this is a pair of sides. This is a pair of angles. I either need another pair of angles or I need a pair of sides. And they gave me BM is congruent to BM by the reflexive property. So here's the other pair of sides. Now I can say the two triangles congruent by side angle side. As soon as I have two congruent triangles, every piece, and there should be six, there should be three sides and there should be three angles. So every piece of the congruent the congruent triangles are also congruent. So angle A right here is congruent to angle C by CPCTC. What does this stand for? Corresponding parts of congruent triangles are congruent. Okay, next problem. The measure of a vertex angle in an isosceles triangle is 80 degrees. Well, let's draw one, okay? You could draw it any way you want. I like to draw mine with the vertex angle at the top. It does not matter. But it tells me that the vertex angle is 80. What is the measure of a base angle? Well, I know the base angles are congruent. And since I don't know what they are, you can call them x. Why does calling them x help you? Well, that gives you an algebraic equation because you know that x plus 80 equals 180 because those are the angles of a triangle. So x plus 80 should equal 180. That means that 2x plus 80 equals 180. That means 2x equals 100. For those of you who are not following me, I just did a little algebra. So that means x is 50. So either one of the base angles would be 50. The measure of one base angle, and again, I like to draw my base angles down here, is 25. Well, if one base angle is 25, so is the other one. So that means 25 plus 25 is 50. What is the measure of the vertex angle? I have another algebra equation. 25 plus 25 plus x is equal to 180. 50 plus x is equal to 180. Subtract 50 from both sides, and x is equal to 130. All right, on this problem, these two are 5. That means these are the congruent angles. These are the congruent sides. If these are the congruent sides, then these two are the base angles. Why? Because they're opposite. So if this one is 2x plus 3, this one is 2x plus 3. So this is going to be a really long algebra equation, but 2x plus 3 plus 2x plus 3 plus 3x minus 1. This is one base angle. This is the other base angle. This is your vertex angle. All three of those angles have to add together to equal 180. So I'm going to combine like terms on this side. 2x plus 2x plus 3x. I believe that's 7x. 3 plus 3 is 6. 6 minus 1 is 5. And that equals to 180. 7x. We're going to subtract 5 from both sides. So 7x is equal to 175. Divide both sides by 7. And x is equal to, I'm grabbing my calculator, 175 divided by 7. That's 25. Now be sure you read the question. We just found x. Does it say solve for x? Yes, it does. It says solve for x. So that's all we have to do. But a lot of times it doesn't say solve for x. It says find the measure of each angle. And if it did say that, then we would have to go ahead and plug in 25. Explain why the measure of angle 1 is equal to the measure of angle 2. Anytime I have a busy picture, I like to simplify it. This is PQR. I don't have that little triangle in the middle. And this is QTR. Now, PQ, that's this one, is equal to PR. Those are the legs. That means this angle is equal to that angle. Now see, notice that that's this big angle. So that's 1 and 3 together. So that means that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 2 plus the measure of angle 4. Now in this triangle down here, they tell me that TQ, this side right here, is equal to TR. Well, if these are the legs, that means these little angles, which are 3 and 4, okay, those are equal to each other. Well, if 3 and 4 are equal, let's take them away from this side of the equation. What does that mean? The measure of angle 1 is equal to the measure of angle 2. Is it a proof? No. Kinda. I verbally gave you my explanation for both sides. I just didn't write it down. So I would just explain, the only thing I would say right here is that because 3 is equal to 4, measure of angle 3 is equal to the measure of angle 4. I can take 3 and 4 away from both sides, and the measure of angle 1 is equal to the measure of angle 2. Use the isosceles triangle theorem to explain why equilateral triangles must be equal angular. Okay, so equilateral, all sides are congruent. So let's consider these two sides. well, no, let's do this one because these are the ones that we normally do. So this side is congruent to this side. If that's the case, then we know that this angle is congruent to that angle because they're base angles. Well, now let's consider that this side right here is equal to this side. These two sides are congruent. That means that this angle is equal to this angle. Well, if these two angles are equal and these two angles are equal, then that means these two angles are equal. So we've just proven that all three angles are equal. That means it has to be equilateral. Carly says that if an isosceles triangle is obtuse, that's pretty easy to draw. Isosceles, these two sides are the same, and this is definitely obtuse. She's saying that this must be the vertex angle. Is she correct? Absolutely. Because why? You can't have two obtuse angles. If two obtuse angles are in the same triangle, then the sum of the angles would be greater than 180 degrees. Obtuse means greater than 90. So greater than 90 plus greater than 90 is going to give you greater than 180. So these two right here could not be both obtuse. It has to be the vertex angle. Again, if the obtuse angle was the base angle, then you would have two obtuse angles because you have two base angles. And if you have two base angles in the same triangle, then the sum of the angles would be more than 180. You can't have that in a triangle. What's the converse of the isosceles triangle theorem? The converse just means reverse the order. The isosceles triangle theorem says if you have an isosceles triangle, then your base angles are congruent. So this one would say if two angles in a triangle are congruent, then it is an isosceles triangle. So the difference is, what do you start off knowing? In the isosceles triangle theorem, you start off knowing you have an isosceles triangle. And from that, you gain knowledge about your angles. Here, you start off knowing you have two congruent angles in a triangle. That means that it has to be an isosceles triangle. So in triangle ABC, now I'm going to draw a triangle, but I'm not going to put the letters here. I like these to be my base angles. They don't have to be, but I like them to be. So I'm going to call that angle A and angle C because it tells me that they're congruent. Well, that means that this one up here has to be called B. So if side AB is 4x plus 25 and side BC, and this is only possible because I have a picture, and AC is 3x minus 15, then I can find the lengths of all three sides. That just means I need to solve for x. Well, if these two angles are congruent, the side opposite that angle and the side opposite that angle, they are congruent. So that means that you can write an algebra equation. 4x plus 25 is equal to 2x plus 45. And now we just solve for x. So I'm going to subtract 2x from both sides. I'm going to subtract 25 from both sides. 25 from 45, I think that leaves me 20. So x is equal to 10. Now, they didn't ask me to solve for x. They asked me to find the length of the three sides. So the length of AB is equal to 4 times 10, that's 40, plus 25, that's 65. If AB is 65, then so is BC. BC is 65. And you can try it out and see. 2 times 10 is 20, plus 45 is 65. And then AC is 30 minus 15. I believe that's 15. Look at your fold and your cutout. Okay, so I think they want me to go back to this. My fold and my cutout. That's this right here. This blue line. Look at that. It says, what appears to be true about the segment that's determined by the fold? What's true about this blue line right here? Well, I'll tell you what I think is true. I'm laying it on my tablet. My tablet has these little dots. And if I line the fold up with the little dots, that's a vertical line. And notice, I can slide it up maybe so you can see better. The bottom edge of this is lining up with the horizontal dots. So I've got vertical dots lining up and I've got horizontal dots lining up. So what does that tell you about this angle right here? It should tell you that it's a 90-degree angle. So we already knew, so we know that this right here, we would say that the fold is perpendicular to the base. That's what I would say. The fold is perpendicular to the base. And then part B right here says, what geometric term can be used to classify this segment? Okay, so the segment that we're talking about is, again, this one right here. Well, this one not only is perpendicular to the base, but it also bisects the base. So what geometric term would call this segment? We would call it the perpendicular bisector. It's perpendicular because, well, it's pretty easy to see right there that the fold is perpendicular to the base. So we've got a 90-degree angle right there. And we already know that it's perpendicular because this side maps over to this side. So they coincide, so that means they're congruent. So what appears to be true about the segment? It's perpendicular to the base. What geometric term? It's perpendicular to the base and it's the midpoint of the base. So those two things together, we call it the perpendicular bisector. All right. So that gets us through all of the problems. That means it's your turn now to check your understanding and to do the lesson practice. My next and last video for this section will be the answers to the check your understanding and the lesson practice.